Yo, what up, peeps? Molarity here. Hey, this is, you have seen me in such fine quality, epic chemistry educational videos as Introduction to Molarity, Concentrate, and Liters and Moles. The connection? Okay. This is the third video that I am doing here regarding molarity. I decided to go ahead and break it into smaller pieces as opposed to making a longer video. Okay, and the first video I had you talked about what was molarity and the concentration and all that. And then the second video we worked on a relatively simple molarity problem. Okay, as an example. Now we're going to work on something a little bit more challenging, and if you have no clue what I'm talking about, check out those other videos before you get to this one. Okay, so here's what we have. It says here, what is the molarity of a solution composed of 8 grams of potassium iodide, otherwise known as Ki, dissolved in enough water to make 125 milliliters of solution. Okay. Well, we need to know what our molarity formula is, and we know that molarity is equal to moles over liters. Okay? We know that. Now, I would like to point out that we do have a volume, and our volume is right here because they said 125 milliliters of solution. But can we plug in the 125 milliliters here? No, we can't, because milliliters are not the same as liters. You'd say, but wait, if I plug in the 125 in there, aren't I going to come up with the same numbers? Yeah, but it's going to even be weaker. It's going to be more diluted, and of course now it's not going to do what you had intended it to do, and you are going to look rather silly in front of all your friends. So, how do you do this? Well, we know that we've got to change. We have to change the 125 milliliters into liters. We must do that. We have to do it the appropriate volume. Now, how do we do this? And that is where that metric system comes into play. And, okay, how many milliliters are in a liter? Now, for those of you who grew up with the metric system your entire life, you're good. You already know the answer to that. I'm talking to those people who are going, huh? What's a milliliter? Okay. Milliliter is 1/1000th of a liter. So it takes 1,000 milliliters to equal 1 liter. Okay? Basic metric thing here. So, if I want to change this, I've got to go 125 milliliters divided by 1,000 milliliters to 1 liter. Okay? And what you'll notice, you'd say, but how do I know how to divide? Well, because you know what? The milliliters will cancel out because anything over itself is 1. Okay? Apples over apples, berries over berries, Kanye over Kanye. It's 1. Basic math law. So milliliters over milliliters is 1. So that means we're left here with that 1 liter that's going to end up with 125 divided by 1,000 liters. So we know it's going to be less than 1. Okay. So that would mean if we punch that on the calculator, we would end up getting our final volume of 0.125 liters. We can do it that way, or we could just simply say, hey, I know that 125 divided by 1,000, I can move the decimal place 1, 2, 3 places to the left, because when you divide, you get to move the decimal to the left. And if you multiply, you move to the right. Right. Okay. So now we got our volume. Fantastic. Where are we in this formula? Because there seems to be numbers coming out and all that. So let's look at this. So molarity is equal to moles over 0.125 liters. Yay! We got part of the solution done. Fantastic. Now we got to deal with moles though. Wait. What's moles? What's moles again? What? Moles. Well, you might remember over up here, they gave us 8 grams of potassium iodide, Ki. Okay. So now we have 8 grams of potassium iodide, but now we got to change that into moles of Ki. But why do we have to change it to moles? Well, remember, you've got a mass, you got this weight, and now you've got to change it to numbers. And remember, in stoichiometry, it's all about numbers. We have to change the mass of our stuff into numbers. How many of these potassium iodide molecules are we going to have? We'd say, well, it's this giant number. Yeah, that's true, but we do have a way to deal with that. We call it the chemist's dozen. You might remember the mole. If you don't know what I'm talking about, check out my other video in the stoichiometry playlist, because that should help you out. Okay, so how do I go about this? Wait, do I multiply? Do I divide? What? Here we go. We're going to use our non-Illuminati brand triangle. We have our grams, we have our moles, and we have our grams per mole. Okay? Now, what am I trying to find? I'm trying to find moles. Well, the nice part about the triangle is I can go ahead and cross out, because this is what I want to find out, right? This is what is unknown to me, which means now I'm left with grams, and I'm left with grams per mole. So if I go into the second triangle and I fill in the information, you may notice I still need grams per mole. This is my X. That's what I'm shooting for, the number of moles. And I've got 8 grams. Okay, so I already have my 8 grams. So I already filled up the top part of the triangle, right? So now look at this. Here's what I'm trying to solve for. This is what I got from the problem. Okay? Now, I look at this, grams per mole, grams per mole. If you don't know what I'm talking about, do check out the earlier videos, okay? Because I've had plenty of colleagues go and do these videos. But they are on the channel. Check out the stoichiometry playlist. It's there. Okay, so grams per mole. We need to figure out how many grams there are in a mole of. Well, here's the potassium. Now, the potassium is 39.10 grams per mole. How do I know? My periodic chart. My little periodic chart. It's such a wonderful friend. Not my only friend, thank goodness. So, I got potassium over here. 39.10. Did I nail it? Here's iodine. Iodine is over here, and it's 126.90. Woo! 126.90. Here's iodine. We're going to add those up, and now we have 0, carry the 1, 10, 60, carry the 1, 6, 166 grams per mole even. Ooh. So what is that going to look like? So where do we fit on this triangle? So I go back to the triangle, my non-Illuminati triangle, okay, and you may notice that this is my X. This is what I'm trying to find, my moles, right? Here is my 8 grams, and over here, my 166 grams per mole. So I am now actually able to fit this in the triangle. So now I know where it is. I found my grams per mole because I added that up, which I got from the periodic chart. This is what they originally gave me. Wait, what? Oh, okay, do I divide? If I divide, do I multiply? Help me out here. Chill, we got this. If you look, the 8 grams is on top of the 166 grams per mole. Guess what? We get to divide that. Because if it was across like this, then we would need to multiply. But that's not the case because we're trying to find the number moles. That's our X. So here's our 8 grams over 166. So that means we're going to have to divide. Okay, but what are we dividing? Do we divide 166 by 8? You could. It's just you're going to get the wrong answer! So, what does that mean for us? That means we're going to have to take 8 divided by 166 because that's what you need to do. And that's going to tell us how many moles of Ki we've got. So I'm going to have to whip out my handy-dandy calculator. 8 divided by 166 equals, and I got 0.048 moles of Ki. Yay, we're done with the problem, aren't we? One more step. One more. This is the home stretch. Because we're almost there, guys. This is it. All right. I got to take the hood off because this is it. It's time. Crack the knuckles. Do the stretches. Oh, okay. Now. Wait. Molarity. I'm confused. Where are we in all of this? Watch this. So molarity is equal to moles over liters, right? Well, we figured out our liters earlier up here as 0.125. 0.125 liters. We got our moles right here. So that's going to be 0.4, oops. Whoa, hey, nope, not that. That's what I want. Okay? 0.48 moles. So this is what we've got, ladies and gentlemen. Oh my gosh. This is our last step, and we get to divide according to the molarity formula. Oh my gosh, this is, the excitement's overwhelming. 0.048 divided by 0.125, and we get ourselves 0.384 molarity, or 0.384 moles per liter. Dun, 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 dun. Congratulations. You now learn to solve a molarity problem given that they don't give you the moles and they don't give you the liters. The secret is change the milliliters to liters and change the grams into moles using that non-Illuminati triangle. This is Molarity signing off. Have a good one. Ah! Earthquake! Ah! Ah! Ah!